Good evening everyone. We are going to discuss about the sets chapter. This is the first chapter in mathematics. Okay, so what is given in this chapter? Okay, this sets is developed by the scientist named by George Cantor. Okay, so George Cantor. So he developed this. Okay, so George Cantor developed this set chapter. Okay. So he explained what is sets and the representations, and okay, what he said means in sets what we discuss about the numbers, the real numbers. Okay, so what are real numbers? Real numbers include the natural numbers, integers, rational numbers, real numbers. Okay, and positive integers. This is the positive real numbers and this is the positive real numbers. Okay, so what is this? It is natural numbers. Natural numbers, this is integers. This is rational numbers. This is set of real numbers. Okay, so set of real numbers, and this is already we know that Z represents the integers and Z plus is nothing but positive integers, and this is okay, already we know that Q is nothing but rational numbers, so this is known as positive rational numbers, and this is positive real numbers. Is it clear? So these are the terms we use on the number line. Okay, so do you know what is meant by number line? If this is the number line, okay, so number line starts from minus infinite to infinite, and this is the central is that is 0. Okay, so this is nothing but the number line. So in this number line from 0 to the right side, about which values do we get? We get plus values, I mean positive values. So 1, 2, 3, 4 and so on. Okay, on the left side from 0 to the left side, the values will be the negative values, minus 1, minus 2, minus 3, minus 4 and so on. Okay, so this is nothing but number line. Okay, so first one, what is natural numbers? Natural numbers starts from 1 to infinite, so this is natural numbers. Okay, now another thing we have W, this is the whole numbers. This whole number starts from 0. Okay, so it starts from 0 to plus infinite is nothing but whole numbers. Okay, and this set of integers, right? So it is set of integers. Z is nothing but set of integers. So set of integers means from minus infinite to infinite is nothing but the set of integers, Z. Now we will discuss later about these rational numbers. Next one is set of real numbers. So real numbers are nothing but Z. Okay, so integers, positive set of integers, these are also known as real numbers. Okay, so real numbers means plus infinite to minus infinite. Okay, so real numbers. What is positive integers? Integers means from minus infinite to infinite including 0 is nothing but integers. Positive integers means from 0 to infinite is nothing but is positive integers, and similarly from minus infinite to 0, this is nothing but the negative integers. Okay, negative integers. After this, what we have to discuss, everything completed, right? Rational numbers. So what is rational number? Rational numbers is nothing but set if it is in the form of P by Q. So what is here? P is the numerator, Q is the denominator. If the value is if the number is in the form of P by Q, okay, then it is said to be rational numbers. So but one of the condition for this rational number is Q must not equal to 0. Okay, so why is this condition? What is the use? They are saying that Q is must not equal to 0. Okay, so to know that, let's take as Q is equal to 0, then this rational number is equal to P by Q, and we took Q is equal to 0, then P by 0, what will be the value then? It is infinite. Okay, so now we are getting rational numbers as infinite if we take the denominator value as 0. For that purpose only we are taking. Okay, so Q is not equal to 0. So this is called the rational numbers, and we can take the values from minus. Okay, so even minus infinite to -1 and 1 to infinite. We can take any values. Okay, what if Q is equal to 1? If Q is equal to 1, then what will happen? Rational numbers is equal to P by Q, and Q is equal to 1. This is nothing but P, which is nothing but resultant will be the real numbers only. So real numbers are also equal to the rational numbers if Q is equal to 1. Understood? So now, okay, what if Q is not is equal to 1? If it is 2 or 3, then you will get the values between here 1, 2, 2, 2, 2, 3, like 2.5, 2.1, 2.2, 2.3. Or these are all nothing but rational numbers. For example, if I take Q is equal to 2 and P is equal to 10, then what will happen? Q is equal to P by Q, which is equal to the 10 by 2. The answer will be the 5. Okay, so 5. Okay, so the answer will be the 5, and so we can 5 is also a rational number. Since if Q is equal to 1, then what is the value? Then you will get the P is equal to R. R means real number. So all the numbers in the number lines are nothing but rational numbers, and the rational numbers points also include that the values between 2 points. Okay, so 1 and 2 between all the points are nothing but the rational numbers. Okay, let us consider now Q, P and Q. So if for example P is equal to 3 and Q is equal to 2, then what will happen? 3 by 2, this is nothing but 1.5. So 1.5 lies between 1 and 2. So 1.5 here. So this is nothing but the rational numbers. Okay, so this is the number line. This is the introduction given in the set chapter. Okay. Okay. Okay, now we have to discuss, okay, two methods representing the set. Set is represented by representation. Set representation. This representation can be done by two types. Okay. So one of the type is set builder form, and the second one is a roster form. Roster form or tabular form. So these are the two types of we can represent the sets in these two types. Okay. So for example, I am main rules in set chapter is set names are denoted by capital letters. Okay, and elements are represented by the small letters. Okay, numbers or even words. So this is the elements. So this is the set names. Set name is, okay, we will discuss this. Set the name of the set is represented by or denoted by the capital letters, and the elements are denoted by the small letters. Okay, what is meant by set? Set is nothing but collection of objects, elements or members. So all this collection of all this is nothing but the set. Okay, so one of the two conditions I considered. Okay, so set builder form. So in set builder form, if I consider one of the set and I gave the name as capital A, since the name of the sets are represented by the capital letters. Okay, so this is the, and if I consider the vowel numbers, okay, not all numbers, vowels, right? Sorry, vowels. So vowels means what are there in alphabets? In vowels is nothing but A, E, I, O, U. Okay, this is nothing but this is the set. But there is a mistake I wrote here. What is the mistake? Each letter must be separated by the comma. So each letter must separated by the comma. Okay, so first letter, we cannot place any comma before and after last letter. Okay, so this is, now it is representation. Okay, so there is one of the condition in set, that is, okay, there is another set B, and it has the value like A, I, O, U and E. So all these two sets are equal. Yes, equal, because sets is independent of order of arrangement. That means we can write any way. Okay, so it is not depending on the order, that it must be from increasing order, decreasing order. We can take values any type. Okay, we can arrange any type. And another thing, for example, I include here another letter A. So is this a correct set? This set will be the wrong, because in sets no letter must get repeated. So here it is getting repeated, right? So this is a wrong set. So if I remove this, then it will be the correct set. That means repetition is not allowed. Repetition is not allowed in sets. Okay. So this is the some fundamental concepts in this chapter. And this is the, okay, this is nothing but this is the form of the set builder form. Okay. What about in roster or tabular form? Okay, this is the concepts I have explained you in set builder form. These are the representations of the representation of the names of the set, and this is the representation of the elements, and this is the two types of the sets. By this set I have explained you those 2 points, that is independent of order of the arrangement. If you see these two, so letters are same. Here, E is here and E is here. I here, O here and U is here. That means order I changed. So do they are equal? Yes, those two sets are equal because it is independent of order of the arrangement. Okay. Another thing. So repetition is allowed in sets? No, repetition is not allowed. If I write here O again, so this will be the wrong set. Okay, because repetition is not allowed in sets. Okay. This is some concepts, fundamental concepts in sets. And this is the representation of the set builder form. Okay, so now we will discuss about the roster form. So roster form is nothing but, to write the roster form there is certain rules, that is if I represent A as the name of the set, one of the set, it is named by capital letter A. So there is condition that we must write X such that X. Okay, this too is read as such that. So we have to read X such that X. And X is equal to 2n, and n belongs to capital N. So what is meaning of this? Okay, what is the meaning of this statement? I wrote this in the form of the roster form. The first condition is we have to write X such that X. Okay, X is such that. Okay, so X values are, the formula of X is 2 into n. Okay, so this is the formula I gave. The x value is nothing but the 2 times of the n. But what is n? It belongs to capital, and capital numbers are nothing but the natural numbers. And natural number starts from 1, 2, 3 and so on. Okay, and so on infinite. And what about this condition? They said, okay, so let us take n is equal to 1. If n is equal to 1, then x is equal to 2 into n is equal to 2 into 1 is equal to 2. Isn't it? Nothing I did. I just took the n value as 1 because natural number starts from 1. And I just substituted 1 in the place of n. I got the 2. So if I consider the next number in natural numbers is 2, then x is equal to 2n is equal to 2 into 2 is equal to 4. Okay, similarly, if I take n value as 3, then x value will be the 2 into n is equal to 2 into 3 is equal to 6. So, this is the answer. This is the values for x. Because x is equal to 2n, isn't it? So, 2n value is nothing but 2. Therefore, x values are, we can write this, x values are 2, 4, 6 and so on, infinite. So, this is called as, okay, I considered the question in the form of a roster or tabular form, and I converted this question, okay, this statement into this form into the set builder form. That is nothing but we can say that the values of x are nothing but even numbers. Okay, so this is the differences. What type of questions do they ask in exercises or in examination? They give any one of the form. If they give the form of roster form, and they may ask you to solve that and obtain the set builder form, or may ask if they give set builder form and they will ask to convert into the roster form. Okay, so this is the condition. So can we solve that? Okay, let us take by this example I have showed you that what is roster form. Roster form is represented by this type, and I solved one of the example. Okay, so this is one of the example. I considered the roster form and I obtained the set builder form. Okay, similarly let us consider the set builder form and obtain the roster form. Okay, so roster form let us take now. A is equal to 1, 3, 5, 7 and so on n. Okay, so this is the this is in the form of set builder form because elements are separated by comma. Okay, another thing. So this set builder form of sets are of two types. One is finite set, another is infinite set. What is finite set? Finite means which is having countable elements. Okay, we can count. Okay, that is nothing but finite set. So finite set is countable. Elements are countable elements. For example, initially I wrote the example A, E, I, O, U. So this is the example for finite set because the only 5 elements are there. A, E, I, O, U. No more elements you can write there. So that is nothing but finite set. What is infinite set? Infinite set is uncountable elements. Like A is equal to 1, 2, 3 and so on n. So this is nothing but n. It is ending by n. So do we know what is n? Can you say what will be the value? Okay, or can you count how many values will be there between 3 and n? We cannot count. So that is nothing but okay, infinite set. The condition it starts from 1 to n. That is nothing but I can take here infinite. So 1 to infinite is nothing but the natural numbers. Okay. So this is the two conditions for finite set and infinite set. Okay. Now tell me what is this condition? Is it finite set or infinite set? It is an infinite set because I put here dots. And I can write here up to infinite or n, anything I can write. Infinite. Okay, so now I wrote in the form of set builder form. Now I have to convert this set builder form into the roster form. Okay, so how can I convert? So what are the values here? 1, 3, 5, 7. This is nothing but odd numbers. So I notice that these are the odd numbers. So what is the condition to write the roster form? So what is the name of the set? It is capital A, and the condition is we have to write X such that X equal to, so we have to write the formula for this odd number, okay, and X we write the formula in terms of N, okay, so and N belongs to capital letters N, that is nothing but N belongs to the natural numbers, and we have to write the formula in terms of N, okay. So how to write the odd numbers? So odd numbers means nothing but initially even means what I took 2n, then odd means we can get two values, two types, we can write two types, okay. So it is 2n minus 1 or 2n plus 1. So which condition, which formula do we have to write there? Because here why I am doing plus 1 or minus 1? Because 2n is nothing but even. If we add plus 1 to the even, then it will become the odd. For example, even considering, I am considering 4 number, for it is a even number. If I add 1, then it will be the odd number. If I do minus 1, it will be the odd number. So two conditions I wrote, 2n minus 1 and 2n plus 1. So what is, but which formula should I write here? So see here. So here n is nothing but the natural numbers, right? So natural numbers starts from 1, 2, 3 and so on, infinite. Natural numbers. So what we have to place in the place of n? So 2n minus 1, so n value starts from 1 is, and I have to do the minus. So 1 minus 1, it will be the, sorry, it is 2 under 2, right? So 2 1 minus 1, it will be the 1. So it is getting verified, isn't it? So we are getting the first value 1. So now, so first value we obtained. If we take n value as 1, if n is equal to 1, then I got this. If n is equal to 2, because why I am taking 1, 2? Because we took the natural numbers. We said that n belongs to n and the values are 1, 2, 3 and so on. First I took the 1 and I got 1 value. So this is verified. Now I have to take the value 2. So I have to do the 2n minus 1, 2. The value of n is 2. So it is 4, 2 2s are 4. 4 minus 1 is equal to the 3. So this formula is correct. We have to choose 2n plus 1 formula. So what I have to write here? 2n minus 1. Okay. So this condition is verified and our we have successfully converted the set builder form into the roster form. Okay. So now, what about this formula? So what about this formula? So that formula example I wrote here. Isn't it? 2n plus 1 is equal to, it is also giving the odd number, but why I did not consider that? Okay, so for this formula, if I consider n value as 1, then it will be the 2n plus 1 equal to 2n plus 2 plus 1, it is the 3. So if I place n value as 1, I am getting the value x value as 3. X value as x value as 3. But if I but this is wrong. Okay, this must be wrong, because when I take the n value as 1, the x value must be 1. It must not be 3. Okay, that's why this formula is getting failed. We do not write that formula. Okay, so this is nothing but we have solved set builder form. If they give question, we have to convert into the roster form, and earlier I explained you that if they give in the roster form, how we have to convert into the set builder form. Okay, so this is the representation of the sets, two types, set builder form and the roster form. Okay, so by this whatever we discussed, you can solve the exercise 1. Finite set and infinite we have discussed. Countable means finite set, uncountable means we cannot count. Those set is nothing but infinite set. Okay. Subsets. now what we have to discuss, the concept subsets. Okay. Subset. It is represented by this symbol. It is represented by this symbol. Okay. This is the symbol for subset. So what is subset? Subset means for this subset, how many sets we must require? We must require 2 sets. That is nothing but we must require 2 sets. Let us take that as capital A and capital B. Okay. So I have the elements in A 1, 2, 3, 4, and I have the elements in B as 2, 3, 4. Okay. So now I have to show that A is subset of B or B is subset of A. So which condition is true? How can we solve this? Subset. What is the subset? What is the meaning of subset? Subset means the element which is present in the left side, all the elements in this set must be present in this set. What is the definition? All the elements in the left side set, all the elements must be present in the another set. Right side set. Okay. So what are the elements in left side? It is A. So what are the elements here? 1, 2, 3, 4. Subset. And what is the B set elements? It is 2, 3, 4. What I have said to you, all elements must be present on that set, but 2 is present, 2 present, 3 present, 4 present, but 1 is not there, right? So but what is the condition for subset? All elements present in this side, in this set must be present here. Okay, must be present here, and even this set may have more values than this one. Okay, so this is not there, so this is not a subset. Okay, so see this condition now. So what is the elements? 2, 3, 4, and what are the elements here in A? So what are the elements here? 1, 2, 3, 4. Okay, so these are the elements in 2 sets. Now see here, what is the condition for subset? All the elements in this side must be present in that set. Okay, so 2 is present here, so 2 is there, 3 here, 3 is also there, 4 here, 4 is also there. So all the elements are present here, so this is a subset. Okay, so this is one of the condition. So this is the correct. Okay, so always it is not correct. This subset will depend on the values whatever present. Values means elements, members or objects. It depends on this symbol. Okay, this subset, it is subset or not a subset, depends on the elements of the sets. Okay, so how many times we can write? Okay, so this is the condition I wrote here. So is 2 is also a subset of? Is this correct or wrong? Here, what are the elements in B? It is 2, 3, 4, and I consider the value, only one of the value in this set, that is 2. Is this a subset or not? Yes, it is a subset. Okay, even single element is subset of this element. Okay, so single element is a subset of A. That is nothing but all. So it can be 3. 3 is also subset of A, or 4 is also subset of A. That means each element is subset of A. So whatever set is present here, this set, whatever elements it has, all elements, a single element is also a subset of this. Okay, now if that element is present here. Okay, so now consider here 1. So 1 is subset of A. 1 is there. Okay, what I wrote here B. So B has any one value. Is it has element 1? No. So I cannot write like this. And now consider this type of question. B is subset of A. Okay, B is subset of A we considered. Let us consider this type of subset. A is subset of B. Here 2, I am writing 2. Is this a subset? See the element in A. So element A has 2. And is this element is present here? Yes, it is present. So this is a subset. Now I am writing 3. Is 3 a subset of B? So 3 left side it is A. So set A has 3, and set B, right side set B. Set B also 3. So this is also a set. Now let us consider 4. 4 belongs to B. Set element 4 belongs to B. So A has 4, and this is subset of B, means is it present in B? Yes, is it present? So these are the subsets of the B. So now consider this element in A. So 1 belongs to 1 subset of B. Is it correct? So 1 is present here, but is 1 is present here? No, there is no 1. So this is not a subset. Okay. So two conditions we discuss. What we discuss? All elements must be present on that RHS side. One of the condition. Second condition is even single element or subset of that set if it is present. Next, third one. Okay. So this is this true? Will it be a subset? Okay, so this is nothing but the null set, or this is called as null set or empty set. Okay, so there is a condition in subset that null set or empty set is always a subset to any set. Okay, so this is a subset to A or subset to B, subset to B, subset to A. It is a null set is always a subset to any of the set. This is also represented by the phi. Okay. So phi is always subset to any of the set. It is subset to all the sets. Okay. So these are the conditions for the subset. Okay. So here you can write. So first point, all elements in left must present in right set. So what is the second condition which discussed? Each element in left set is subset of right set if it is present. Okay, if it is present in, if it is also present in right set. So these are statements. These are my own statements. Okay. So by doing all the by solving the questions. Okay, and by reading the statements, whatever given in the concepts in this chapter. By this, I am writing those conclusions. So 2 points I wrote already. So what is the third point? Null set is always subset to any set. So if we consider any set, the null set will be always a subset. Okay. So those 3 points are nothing but the subset. Okay. So subset completed. By these concepts you can solve. So what is power set? What is power set? Let us discuss here. From this only we can write power set. Put the heading power set. So this is represented by P of n, isn't it? So power set is represented by the not P of n, the name of the set. P of name of set. If the set is A, if set A, elements are 1, 2, 3, and we have to find out the power set of A. So it is what I wrote A because the set name is A, so I have to write here P of A. We have to find out the power set of A. So now for this set, what is the value for power set? So to find this, the formula is 2 power n. The formula is 2 power n. What is the n? N is number of subset it has. Number of subsets are there for this set. So what we have discussed? So single elements are also subset of A, right? So first thing, what is the first one? So by this condition, even null set is also a subset of A, isn't it? So empty set is completed. Now consider the single element. So 1 is also a subset of B, 2 is also a subset of A, sorry it is A. So 3 is also subset of A. So empty set is completed and single sets are completed. Now consider so number of, it is not subsets, number of elements in set. So single elements are completed. Now we have to take two elements, combination of two elements. Let us consider this two combination. So set 1, 2 belongs subset of A, isn't it? Because two elements are already present. Now we have to take 2, 3. So combination of 2, 3 also is also a subset of A. Now just consider 1 and 3. So consider 1 and 3 is also a subset of A. So empty set completed, single elements completed, double elements are completed. What is the last one? It is the all elements. 1, 2, 3 is subset of A. Okay. So how many are there here? 1, 2, 3, 4, 5, 6, 7, 8. So P of A is equal to 8. Okay. So we this is the proof. Okay. So by this formula can we solve? Yes. N is what? Number of elements in this set. What are the elements here? 1, 2, 3. So count is 3 elements are there. So simply put here 2 power n. It is equal to 2 power 3 sin n is equal to 3, because number of elements here is 3. So 2 cube is nothing but 2 2 ja 4, 4 2 ja 8. So by simply by this formula we can calculate the power set, and this is the proof I gave you. Okay, so see here, if we substitute, if you take the direct formula you can solve, or you can come to this process. So this is the perfect one. Within a second you can solve this problem. Okay, but what is the rule of doing so? By this you can go through the fundamental concepts. Even here already we discussed the 3 concepts. Those 3 concepts I covered here. Okay. So first one is nothing but 3. All the elements in set is also a subset of it. Another thing. Another point is each set is subsets of itself. So here, so this is the 1, 2, 3. So this element is 1, 2, 3 is nothing but is A is subset of A. So this is the 4th point. That is every set is subset of itself only. So those are the 4 points, and we have completed this power set, and the formula for power set is 2 power n. And we have done the proof also. So we consider 3 elements. And first we started from empty set, single elements, double elements, triple elements. If you have 4 elements, then you have to write combination of 3 elements. Okay. So it will be a long procedure. Okay. So in objective type you have to solve by this, but in IPE exam you have to go through these procedures. Okay. So this is the concepts about the subset. Okay. Okay, then if you have any doubt you can ask me. Okay. Thank you.